So if we're going to summarize vectors, the first thing is to make sure that we've got all the definitions. So what is a vector? It's a physical quantity with both magnitude and direction, as opposed to a scalar, which is a physical quantity with magnitude only. Some examples of vectors: acceleration, velocity, displacement. You could look at force. Some examples of scalars: speed, distance, time. Remember that if you're making a summary, you need to have this sort of information. This is the bare essentials, the skeleton of what you require. What is the definition of a resultant? A resultant is that single vector which has the same effect as the original vectors together. So we've learned a few things. We've learned that if we've got a maximum, let's say we've got 3 newtons and we've got 5 newtons, the maximum you can get is 8 newtons out of that by putting them in the same direction. 3 newtons and then 5 newtons. If we want to have them at a minimum, I will put the 5 newtons in one direction, doesn't matter which one really, and the 3 newtons in the opposite direction, and therefore the resultant is the subtraction between the two, and that is going to be from there to there. 2 newtons would be obviously the 5 newtons is going to win the war to the left-hand side, and the 3 newtons loses the war to the right-hand side, so it's going to be 2 newtons. And what do you land up with? That is your minimum resultant. So we can always get maximums and minimums. And what is the information? The information, so that was 2 newtons. So what is the resultant of any 5 newton and 3 newton force? It can be any value between 8 and 2 newtons. We've done lots of those examples along the way. The other thing that while we're working in straight lines we need to be aware of is, what if a little car was driving along over here in that direction at 40 kilometers per hour. Simultaneously there's a big truck and it's driving along at 20 kilometers per hour in that direction. They are approaching each other. If you were sitting in the little car over here, you would experience a force of a speed of your 40, and at the same time, this truck would be approaching you at 20. So in total, you would feel 60 kilometers per hour towards you if you were sitting in that car. So relative to the little car, the truck is moving at 60 kilometers per hour. I know they're in opposite directions, but this is a slightly different example. How would the person in the car experience it? So it would be 60 kilometers per hour towards the car. If, on the other hand, this was in the opposite direction, so the 20 kilometers per hour, this truck was moving that way around, and it was moving towards the right, and the little car was gaining on the truck. All the time that the little car is gaining on the truck is moving away from it. So it's trying to gain at 40 kilometers per hour, but the truck keeps going away at 20 kilometers per hour. So relative to this car, this truck is moving at 20 kilometers per hour away from the car. In other words, it is experiencing, because it's gaining, can you see? This 40 keeps on going and gaining on there. So it is getting closer and closer and closer. So it will experience the force, it won't be going away. It will be, this little car will experience itself getting closer and closer to this truck. And therefore this truck, relative to this car, is moving towards the car at 20 kilometers per hour. So be very careful of these relative velocity questions. Don't forget, you may have to convert between kilometers per hour and meters per second, and we've done that a few times. What if my forces are a little bit more complicated? I've got 500 newtons off to the right, and at 90 degrees, 300 newtons. How do I get the resultant? The resultant I get by completing the parallelogram, and then from the start to the finish. Don't try to be clever about it. Go through this whole process. Then I'm going to write 300 over there, and I can easily calculate what I can calculate that angle, and I can calculate my resultant. So let's use Pythag. So we've got Pythag, and we can say r squared is equal to the sum of the squares of the other two sides, and you don't get square root at the end. Then you can say, I know that I'm looking for a little alpha over here. I know the opposite side I know the adjacent side. Let's label those adjacent, opposite, and hypotenuse. So if I know the opposite and the adjacent, I can use tan, and I get 59,04 degrees. Make sure that you can do this on your calculator. Fairly simple and straightforward. What if I say that I need to balance, let's say these were two boats, for example, and the boat was pulling, or like a tugboat was pulling there and pulling over there. But the gate to the harbour was, let's say, over here. So I have to keep on a nice straight course, and this guy keeps pulling down or something. How could I balance this to make sure they stay on a straight course? If I were to pull a force back here by 583,1 newtons, that little boat would continue at a constant velocity, and it would neatly go through that gateway over there. So this force over here is a balancing force. It is equal to the resultant, but it is in the opposite direction, and it balances things out. What if my forces were not exactly at 90 degrees to each other? Grade 10s would not need to worry about this, but grade 11s would need to know that they would still complete the parallelogram, draw the resultant, and now you may have to use your sine rule and your cos rule in order to ensure that you get the right answers. So firstly, we know about a parallelogram that this angle would be 90 plus 30, so it's 120, meaning that that angle over there is 60 degrees. If that angle is 60, that angle over there is 60 degrees. Otherwise, we don't have terribly much information, but we can start finding out the opposite sides of triangles and all sorts of things using the sine and the cos rule. So now you have to use your sine and cos rule to be able to work things out. And obviously this is a little bit more tricky. Only the grade 11s need to worry about it. So what's going to happen now is we've got this triangle here. We know this side's 300, we know this side is 500. And we are interested in that side over there. That side is going to be, why don't we call it A? And then we'll call this B, and we'll call that C, and that's the included angle. If these are 120, that's 60. So let's go. A squared is equal to B squared plus C squared, or C squared plus B squared, it doesn't really matter, minus BC cos of the included angle, 60 degrees. And we find that A turns out to be equal to 514,78 newtons. Check that you can make your calculator do that. The next thing I'm interested in is this little angle over here. Because then I can say, I can work out what the difference is between 30 degrees and that, and I can work out what the bearing is that we are interested in. So to do that, I'm going to use the sine rule, and I am going to say, let's call this angle over here now beta. Let's try and make that a bit bigger. So that is beta, and we are going to say sine of beta over 500 is equal to sine of 60 degrees, because we know this angle over here, 60 degrees, over, and now we know the opposite side to that, which is 514, give or take, all right? Then what we're going to do is we're going to calculate that out. And we find that beta turns out to be 57,4 degrees. If you're not getting that answer, and actually I should have carried it across my complete answer over here, there might be a little bit of a rounding error. If you need to double check with your calculator that you can get that answer. Now remember that part of this was 30 degrees, so take 30 off there, and I'm going to be left with 27,4 degrees, and then we can sit there and we can say, okay, well then what's just this part over here, and that part over there is the 27,4. So it's, the bearing is 27,4. So what's my resultant? 514, something. Let's make 514,78 at 27,4 degrees based on the question that was given. Don't forget, you need to know how to get components. You've got a horizontal component, you've got a vertical component. The horizontal, then we can complete a parallelogram around that, and the parallelogram then lands up with that being the vertical. This is my opposite side, that's my adjacent side, that's my hypotenuse. So sine of 60 degrees is equal to the opposite, or the vertical, over the hypotenuse. Cos of 60 degrees is equal to the adjacent, or the hypotenuse, over 200. And then you can resolve those quite easily.